Hi, 7th graders. We are on lesson 4-7, which starts on page 218 in your textbook. Make sure you have your vocab sheet out and you're filling it in as we go along. Two different learning targets. One is determining if two figures are similar, and the other is finding the missing measurements in two similar figures. So when we're talking about polygons, remember a polygon is any closed figure, and a similar polygon has corresponding angles that are congruent. Remember, congruent means the same measure or just the same, because we're talking about angles, so congruent angles would be the same measure, congruent sides would be the same length. And then corresponding sides are proportional and it's the same shape. So to determine if two polygons are similar, we have to look for these three things. Corresponding parts, when we say corresponding angles or corresponding sides, one of our vocab words is corresponding parts, which means the parts of the similar figures that match or are congruent. So let's look over here at these two triangles. Okay, first of all, we know that the corresponding angles are congruent. We are told that these are right angles, okay? Therefore, these other angles would be the same. So we know that, and we know that they are the same shape. They're both a triangle, so they both look somewhat similar to us, okay? So then we have to figure out, are the corresponding sides proportional? So when we say corresponding, we mean the same, they're the same sides on the figure. So the 3 and the 5 are corresponding. The 5 and the 13 are corresponding because these are both our hypotenuse. And then we have the 4 and the triangle, or the 4 and the 12, which are corresponding as well. So the way that we can figure out if they're proportional is we think back to how we did, how we figured out proportion, or if ratios are proportional, and we can set this up as a ratio. So we can do 3 over 5 equals 5 over 13. Notice that my numerator is always from the same triangle, and my denominators will be from the other triangle. And then we have 4 over 12. So we can simplify these, or we can put into our calculator to figure it out. So 3/5, if I put in my calculator, oops, I get 0.6. If I put 5/13, so I would just do 5 divided by 13, I would get 0.4. I'm going to just round it to the nearest tenth. And right away there, I know that since at least 2 aren't equal, then I know that, and I know 4/12 simplifies to 1/3, which we know is 0.333. So we know that they are not proportional. So this one is not similar because our ratios are not proportional. So these two polygons, you can see, if you look closely, are flipped around. So we can't just go 18 and 6 and 8 and 7 and 7.5 just because they are corresponding in the direction of where they're located. We need to, in our head, kind of flip this around so we can figure out which goes with which. Okay? These half circles right here tell us that the angles are congruent. So this tells me that this angle right here is congruent to this angle right here. Same with the one with 2 and 2, and then we have the 3 and 3. Oops, 3 and 3 is over here, and the 4 and 4. So this can help me figure out a little bit which goes with which. So if I look at my 8 and it's between, I see the 1 and the 2, then I look for the number between the 1 and the 2, and I know that those are corresponding. So since I just figured that out, I'm going to write that as a ratio. Okay, and then I look at my between 2 and 3, and I see an 8. And then between my 2 and 3 is a 6. So right away, right there, we know, oh, those are the same. Those two are similar, those two sides, but let's check out the rest. So then I have between 3 and 4 is 18, and between 3 and 4 is 13.5. Notice that I'm putting everything from this smaller polygon in the numerator, and from the larger polygon, those numbers are going in the denominator. And then lastly, from 4 to 1, between 4 and 1, I have 7.5 divided by 10. And since these are a little bit trickier to simplify and figure out, we can just put in our calculator and figure out what each one is equal to. So 6 divided by 8, we have 0.5, and we know that that's true for both of them. And then if I put 13.5 divided by 18, I get 0.5. And then if I do 7.5 divided by 10 is also 0.5. So since they are all equal, that means that they are all proportional, which means that they are all similar. Because I forgot to mention that we look for the same shape, and they are the same shape even though they're flipped around, and their angles, all of their corresponding angles are congruent. So if we are given two triangles like we are here, and we are told that they are similar, how can we find the missing sides? So again, we look for our corresponding sides, and on my smaller triangle I can see that my 3 is right in between my angle 1 and angle 3, and I can see on this side between my angle 1 and angle 3 is a 6. So I have a 3 and a 6. Because those two, if I look at the rest, between 1 and 2, I have a 9 and I have a y, and then the other one is the 6 and the x. So I'm for sure going to use this one that has both a numerator and a denominator. So I put my number from my smaller triangle in my numerator and my number of the side, length of the side from my bigger triangle in the denominator. And then we're going to set it up as a proportion. So let's find y first. My y, okay, I also know that y is congruent to 9, because if we look at FG is congruent to KL, okay, this sign right here, you might want to add on to your vocab sheet, means congruent. Okay, and since it's written like this, I know that FG is the same as KL. I know that GH is congruent to LJ, and HF would be congruent to JK. So FG, which is 9, is congruent to LK, or corresponding, sorry. They correspond with each other. FG corresponds with LK. So I'm going to put y on the top because that's my smaller triangle, and then 9 on the bottom. And now we solve this just like a proportion. So 3 times 9 is 27 equals 6y. And then we divide both sides by 6, and we get y equals 27 divided by 6 equals 4.5. And we would just say 4.5 units. We can use 3 and 6 again. This time we know that now we're looking for x, and we know that LJ corresponds with GH. So I put my 6 on the top, and I put my X on the bottom because 6 is my small triangle. My smaller triangle numbers are on the numerator, and my bigger triangle numbers are on the denominator. So this time we have 3 times x, so 3x equals 36, because 6 times 6 equals 36. And then we divide both sides by 3, so x equals, 12. So then we could plug these in 12 and 4.5. Okay. So looking at our polygons, we have WXY, WXYZ, and ABCD. And we're told that they are congruent. So what we're going to do, I'm actually going to turn these to make this a little bit easier. I know if it's in your book, you wouldn't be able to do the same thing. But if we turn it, we can see that they are exactly the same. Or they are similar, same shape. We have angles 1, 2, 3, 4, and then 1, 2, 3, 4. We want to find out what M is. So take a second and see if you can set up a proportion yourself and solve for M. So we know that 10 and 15 are corresponding. So I'm going to set it up like this, 10 over 15. And then we know that 12 and M are corresponding because you can look at the angles and you know that 2 and 3 matches up with 2 and 3. You also know that BC corresponds with XY, and here's XY. So 12 over M. So I can rewrite this then. 10M equals 15 times 12, which is 180. And then we would divide both sides by 10, and we would get M equals 18. Okay, one last problem. Quadrilateral ABCD is similar to quadrilateral WXYZ. If the perimeter of quadrilateral ABCD is 54 units, what is the perimeter of quadrilateral WXYZ? So we know that AB corresponds with WX. So we're given AB and we're given WX. So we know that we can set that up as a ratio. And I'm going to put 4 on top because it's smaller. If you did it on, flipped it around, it would be completely fine as long as you match up to what you are given. Okay? So 4 is our WXYZ. We're looking for the perimeter of quadrilateral WXYZ, so we can call that X. And then we're given the perimeter of ABCD. 6 goes along with our ABCD, so that's why we're putting 54 on the bottom. And even though we're given the perimeter, it's still going to be corresponding and it's still going to be proportional, because if these are similar and all these lengths are proportional to each other and corresponding, that means our perimeter would also be corresponding and or proportional. So we would solve just like a normal proportion. So 54 times 4 equals 216. And 6 times x equals 6x. Then we would divide by 6, and we get x equals 36 inches. And because it's multiple choice, we're going to look and make sure that our answer is on there. And we see that it is, and it's J. Okay, make sure you remember to go on to NICU and take the 4-7 NICU quiz. We did not do 4-6. We skipped over 4-6. So look for 4-7. Also look in your book for a lot more examples if you're still maybe a little bit confused. Have a super evening, and I'll see you tomorrow.